Hello, everybody. This is Mr. A again, this time with a question about circuits. Okay, and let me go ahead and read the question to you first. The voltage provided by the battery VT is 60.0 volt. The resistances R1, R2, R3, and R4 are 560 ohms, 590 ohms, 410 ohms, and 320 ohms, respectively. The questions, there are two questions to it. A, what is the total resistance of the circuit? And B, how much current goes through R3? Okay, and the circuit diagram is to your right. And as you can see, the voltage of the battery VT is given as 60.0 volt. And then there are four resistors in the circuit. There's R1, R2, R3, and R4. I'm not going to write the numbers down here because that's just a waste of time. You can very well figure out that 560 is R1, 590 is R2, 410 is R3, and then 320 is R4. The question is asking about the total current in the circuit and the current that goes through R3 alone. Okay, so here is what we are going to do with this. The situation here is that this is a series circuit, which means that this, and this loop are all attached in series so that the negative of the one is attached to the positive of the other, and so on. And this loop here, which consists of R2 and R3, is a parallel loop, which means R2 and R3 are in parallel. So there is a current that flows from here all the way around to here, but as it passes through R2 and R3, it splits up and then it recombines so that B and C combine to form A. All right. Having determined that, let's go ahead and try to solve it. First thing, the two formulas that are relevant. The formula for parallel, which will involve R2 and R3, is that the 1 upon resistance Rp, which is the resistance of the parallel loop, equals to 1 upon R2 plus 1 upon R3. So you take 1 upon the resistance of the whole loop equals to 1 upon R2 plus 1 upon R3. That is the formula for the resistors in parallel. And I'm sure you know that. The second formula that we're going to apply is for series, which is that R is equal to R1 plus Rp, which is Rp from right here. We are going to use that. And then plus R4 to calculate the total combined resistance. Now, what can be done and is relatively simple is you can either do it separately, so you can calculate that and then use that value of Rp in here and calculate that. Or you can use this combination formula. So you have R1 plus this thing in the parentheses is the resistance for the parallel loop plus R4. And after you plug in the numbers for R1, R2, R3, and R4, I get 916.9 ohms, but I urge you to please do the calculation yourself because mistakes happen. And even though I have rechecked it and I am almost certain that this is correct, just being human here, please make sure that you redo the calculation yourself to make sure that you get the correct answer. Okay, next step, moving right along, this is for part B now. The current in the circuit can be calculated using I equals V over R. That's your basic Ohm's law. And to calculate that, you already have the value of voltage, which is 60.0. And then resistance, which has been calculated from here, 916.9 ohms. If you divide 60 by 916.9 ohms, you get this. But once again, remember, redo the calculation. If this comes out to be slightly incorrect, then this will come out incorrect also. Even if this is correct, this could still be incorrect. So please redo the calculations yourself. Make sure that the numbers are coming out right. If they are not, then redo, double check your calculation, and then use your calculation and own it. Okay, so once you do that, you get the current labeled A, which is uh, this one in the main circuit. So current A passes through R1, and on this side, current A also passes through R4. However, when this current reaches this parallel loop, it divides up, and the larger the resistance, smaller the current through it. Even though the sum of B and C is equal to A, individually, if R2 is larger than R3, then there will be more current flowing through R3 than R2. Okay? All right, so having said that, the value of B comes out to be less and value of C comes out to be more. And how do you do that? Basically, all you do is use your ratio and proportion from 6th, 7th grade math. That's all you need to be able to figure out this. All you have to remember is that it's opposite. So the larger the resistance, smaller the current will be. So when you're trying to determine the current through B, or current that is B, which is through resistance R2, you take the value of resistance R3, which is 410, divide by the sum of the two resistances, 590 plus 410, which is 1000. You multiply by the current in the circuit, and you get the current through the branch R2. And then you do the same process here, and you get the other branch. And if you add these two, you should be able to get this current. 0.65. So that's basically it. If anyone has any questions that to clarify this further, please let me know. And also remember that I do offer one-on-one tutoring in high school math and physics. If anyone feels that they need it, or if anyone knows anyone that needs it, please let me know. Okay, then this is Mr. A signing off.